fresh morning standard 8 class. Students, winning is fun, but those moments that you can touch someone's life in a very positive way are better. Yes, with this positive note, let us start with the new lesson, that is lesson number 16, reflection of light. We have completed lesson number 15, that is sound, and now again a physics topic, that is reflection of light. We are going to study together. Okay, so let's begin. Yes, we are going to learn from this video lesson number 16, that is reflection of light. Okay. Students, to start with the introduction, we all know that we get different feelings through senses. Correct? Now, the sense of vision is the most important among our 5 senses. Do you agree with this? Okay. See, because of the sense of vision, we can see the hills, rivers, trees, people, objects around us. Correct? Only with this we can see the beautiful views of nature like clouds, rainbow, flying birds, moon, stars, etc. etc. Correct? So this topic is really interesting because here we are going to understand that how we can see the objects. Okay, so let's start. Okay, students, before starting with the main topic's definition, let us do one activity. So this is activity number 1. What we have to do? We have to switch off the light in our rooms at night for some time, and then we have to turn it on again. When you switch off the lights, could you see the objects in the room clearly when the light was switched off? No, correct? Nothing was seen. Everything was dark. What did you feel when it was turned on again? So here I can see all the objects and articles, everything kept inside the room very clearly. Okay. So what is the inference? There is some connection between the sense of vision and light. Sense of vision means our eyes and light. So there is some connection. Okay. Students, the light entering our eyes may be emitted by the object or may be reflected by that object. Okay. So there are two conditions here. Either the light which is entering our eyes, yes, it is emitted by the object or it is reflected by that object. So now the question arises here, what is meant by light reflected by an object? So we are going to see reflection, okay, as in detail. So what is reflection of light, students? Here we have the definition for reflection of light. Very simple to understand. Students, when light rays fall on the object, when light rays fall on an object, what happens? Their direction changes and they turn back. Yes, their direction changes and they turn back. This is called the reflection of light. Yes, the light rays, they fall on the object. Yes, their direction changes, they turn back, and this complete process is known as reflection of light. So here we have the definition of reflection of light. Understood? Okay. Further concepts of reflection of light we are going to see in the next video. Till then, thank you and take care all. Welcome back to the science class, students. Students, in the previous video, we got introduced to the definition reflection of light. Okay. What is reflection of light? When light rays fall on an object, their direction changes and they turn back. This is called the reflection of light. Correct? This is what the definition was. Okay. So in this video, let us understand an activity based on it. So let's start. We learn in chapter number 16, reflection of light. So let us start with an activity. What materials I have to take? I have to take torchlight, mirror, a stand for hanging the mirror, black paper, comb, white paper, and a drawing board. Okay, drawing board is nothing but table kind of thing. Okay, that on which we are going to perform the experiment or the activity. So what is the activity? We have to take a white paper first of all and tightly cover the table or the drawing board on which we are going to perform it. Now I will take comb. So what we have to do? Leaving out some portion in the middle of the comb, I will cover the rest with black paper. Middle portion I will not cover with black paper. The rest, that is the front and the back side of the comb, will be covered with the black paper so that light can only pass through the open central portion. So that means we are going to pass light through it. Yes, let us see the figure 16.1. This is the figure which is given in your textbook. Can you see the torch light? Then a comb is placed. Okay, vertically it is placed. And the central portion of the comb is not covered with black paper. Now how does it prove? See, when you pass the light of the torch to the central portion of the comb, can you see the backside mirror is placed? Okay, so light rays which are traveling across the comb will strike the mirror and it will get reflected. This is the overview or the overall explanation of the activity. Step by step also we will understand. Hold the comb perpendicular to the white paper and throw torchlight on its central portion. This is what we have done. Adjust the comb and torch so as to get light rays on the white paper. Now keep a mirror in the path of this ray of light as shown in the figure. So I will get back to the figure. Again they have explained the same thing. Mirror is placed at the back side so that light rays which are traveling across the comb, they will strike the mirror and then they will change the direction. They will get reflected. Understood? So observation, let us understand. Students, overall, after understanding the activity, what do we understand? That light rays which fall on the mirror get reflected and travel in a different direction. Yes? Now important definitions we have, all three important lines. Okay, we are going to cover one by one. Which are those lines? Please students pay attention. This is very much important. Okay, the rays falling on any surface are called incident rays. The rays, the light rays which are falling on any surface, smooth surface, rough surface, yes, regular surface, these are known as incident rays. The point at which an incident ray falls is called the point of incidence. Point means that very small point, the very small region where the incident ray falls is called as the point of incidence. Now the rays going away from the surface after reflection. After reflection, these rays are moving away. That rays are known as reflected rays. So incident rays, point of incidence and reflected rays. These are very important terms that we need to understand. Rays which are falling, incident rays. Point at which the incident ray strikes or falls, point of incidence. And the rays which are going away, yes, from the surface after reflection are known as reflected rays. Understood all the three terms? Okay. Further concepts, okay, laws of reflection, we are going to see in the next video. Till then, thank you and take care all. Welcome back to the science class, students. Students, in the previous video we have done an activity where what we have understood? We have understood that light rays which fall on the mirror, it gets reflected and travel in a different direction, in a different way. Yes, that was nothing but reflection of light example. Okay, so in this video, we are going to understand laws of reflection. Okay, there is one figure, okay, which is given in your textbook. We will understand the figure and we will try to define laws of reflection one by one. There are total 3 laws that we are going to see one by one each. Okay, so let's start. We are learning chapter number 16, reflection of light, laws of reflection. Yes, we are going to learn laws of reflection together. Students, the direction of the reflected rays is decided by some rules which are called laws of reflection. Okay, we have seen that light rays which fall on the mirror gets reflected, and this direction of the reflected rays will be decided by certain rules. Okay, let us learn some definitions before learning about these laws. So let us start. Okay, students, this is the figure which is given in your textbook. Okay, please observe it. This is your figure number 16.2, reflection of light. What we have to do, okay, to understand this figure, what we have to do, we have to draw a line PQ showing the position of the mirror. For example, if PQ is your mirror, okay, line PQ is the position of the mirror. I have to draw the incident ray AO. Okay, as per the definition of incident ray, what is incident ray, students? The rays falling on any surface are called as incident rays. So let us take one single incident ray AO. Yes, and the reflected ray OB, means after striking the mirror, AO, that is the incident ray, will fall on the mirror and then it will get reflected. Now this reflected ray is OB. Understood? AO, incident ray, OB is the reflected ray. Okay. After that, draw a perpendicular to the line showing the position of the mirror, that is PQ. Yes, at O. So now we have to draw a normal. Normal means perpendicular line. Can you see N for normal? It is written straight blue colored. So red is incident ray, green is reflected ray, blue is nothing but your normal line which is perpendicular on to the mirror. Okay. Now this line ON is called as normal to the mirror. Okay, as I said now. As ON is perpendicular to PQ, we are calling it as normal. Now, students, angle PON is equal to angle QON is equal to 90 degree. Obviously, when I am drawing a perpendicular line NO or ON, that means angle PON is equal to angle QON, which is equal to 90 degree. Yes, understood. So this is the little kind of mathematic geometrical construction that we have drawn, and we have tried to show the process actually, you know, how the incident ray, once it falls on the mirror, how it gets reflected. So AO, OB and ON. Is it clear? Okay. Now, there are certain terms which are related to reflection, okay, which are as follows that we are going to see. Now, which are those terms? See, students, ray AO is an incident ray. Point O is a point of incidence. Okay. Remember what was the definition of point of incidence? The point at which an incident ray falls is called the point of incidence. So, if you go back, we will see O is nothing but the point of incident. Understood? That is the point where the incident ray will strike the mirror. Ray OB is the reflected ray. Line ON is the normal. The angle AON, students, the angle AON. Let us see that angle AON, where it is. Yes, angle AON. Yes, on the left hand side. Between the incident ray and the normal is the angle of incidence. So students, angle AON is called as the angle of incidence. Can you see that small I is given red colored, small I, that is angle of incidence. Understood? So angle A1 is the angle of incidence. The angle BON between the reflected ray and the normal is the angle of reflection. So let us see that angle of reflection where it is. Okay, normal and reflected ray we have. And can you see angle BON or NOB? Small r is given, that is nothing but angle of reflection. Okay, so these are certain terms that we have understood. So let us define laws of reflection. Students, there are three laws of reflection. Which are those? See, let us see one by one. The very first law says the angle of reflection is equal to the angle of incidence. That means angle I is equal to angle R. What is I? Angle of incidence. What is R? Angle of reflection. So both are equal. This is our first law of reflection. Second, the incident ray, the reflected ray and the normal all lie in the same plane. Yes, all lie in the same plane. Okay. The incident ray and the reflected ray are on the opposite sides of the normal. Yes, they both lie on the opposite sides of the normal. We have drawn the normal at the center, right? At the center of incident ray and reflected ray. So here incident ray and reflected ray will be lying on the opposite sides of the normal. Okay. Angle of reflection is equal to the angle of incidence. The incident ray, the reflected ray and the normal, everything lies in the same plane. The incident ray and the reflected ray, they are on the opposite sides of the normal. So these were the three laws of reflection. Students, write it down twice, thrice, and please by heart it. Very, very important. Yes, because in standard 9th and 10th, you are going to carry this basic concept of laws of reflection to study light more in detail in upper class. Okay. Further concepts we are going to see in the next video. Till then, thank you and take care all. Welcome to a fresh morning standard 8 class. Students, if you want light to come into your life, you need to stand where it is shining. With this note, students, let us continue our journey where we are learning different terms related to reflection of light. We have seen up till now the definition of it. We all have got introduced to laws of reflection, yes, with the help of activities. In this video, we are going to understand one more activity, okay, to verify the laws of reflection. So, are you all ready? Okay. We are learning chapter number 16, reflection of light. So, this is activity number 3. So, let us understand this. What equipments do we require or materials do we require for this activity? Is a mirror, drawing board, pins, white paper, protractor, scale and pencil. So these all materials or equipments we would require to understand this activity. Okay. So I'm going to read out step by step and the figure is in front of you. This is nothing but figure 16.3 which denotes the verification of the laws of reflection. Okay. The very first thing we have to take is we have to take a white paper on the drawing board. Yes. And we have to fit it tightly as much as possible. Okay. Fit it with the help of pins. On the paper, draw a line PQ indicating the position of the mirror. Okay, now you can see the line PQ. That is nothing but it is indicating the position of the mirror. Afterwards, we have to draw a perpendicular ON to PQ at the point O. Yes, with the help of the protractor, okay, you can take the point O as the midpoint of PQ and then you can draw the perpendicular, okay, with the help of the protractor. 90 degrees you have to mark at N and then draw a straight line. Understood how to draw the normal here or perpendicular line ON? With the help of the protractor you will do this. Okay, similar way how you draw angles in mathematics, similar way we have to draw ray AO making an angle of 30° with ON. So you are going to keep the protractor on ON, the straight line, and then you are going to draw the ray AO, okay, making an angle how much? 30°. Understood the steps? With the help of ON, I am going to draw ray AO. Now, fix two pins S and R along AO. Can you see S and R? Round circles they have shown. That is S and R. Two pins we are going to fix there. Okay, drawing pins. Now, fix the mirror to a stand and place it along PQ. Okay, you are going to place the mirror. First, you have just drawn the line. Na? That is nothing but the position of the mirror. Now, I am going to actually place the mirror. Fix, okay. Now fix pins at TU along the line joining the bottom of the reflected images of the pins at S and R. Now we are going to fix the pins at T and U along the line joining the bottom of the reflected images. So wherever the reflected images, there I am going to place 2 points. Here the line OT is not drawn yet. Okay, the straight line we are not going to draw. We are just going to fix the pins at the position U and T. Okay, that is nothing but the reflected images. Now remove the mirror and join the points. See, after placing the mirror, I am going to mark the points U and T because it is, see, AO, okay, this is the incident ray that will get reflected. So that reflected image I have to mark it as U and T. Understood? Now remove the mirror and join the points T and U. Initially only small holes were there, circles we have made. Now join these two points so that a straight line can be drawn. We are extending it to O. Now measure TON. See, we know the measurement of angle AON as 30°. Now I will measure angle as TON. And I'm going to see what is the measurement of it. Students, it would be 30 degrees Celsius, 30 degrees. Okay, sorry, 30 degrees. Repeat the steps 4 to 9 for angle of incidence. Okay, equal to 45 degree, 60 degree. Means initially I took 30 degree. Now next I will take 45 degree. Next angle of incidence will be 60 degree. Now if you observe closely after drawing this or after carrying out this experiment, you will understand one thing, that angle of incidence is equal to angle of reflection. This is what law of reflection that we have learned. Okay, the very first law we have learned. So when you measure angle of incidence 30 degree, similarly angle of reflection is 30 degree. 45 degree if it is 45 degree. Then for 60 degree it is 60 degree. Okay. So what relation do you find between the angle of incidence and the angle of reflection? Students, if you have done the experiment carefully, you will find that the angle of incidence is equal to the angle of reflection in all three cases. Which cases? When angle of incidence, first we have taken 30 degree, then 45 degree, and then 60 degree. And this verifies the laws of reflection. The very first law, angle of reflection is equal to the angle of incidence. This was the first law, and this particular activity verifies, yes, verifies the laws of reflection. I hope you have understood this activity. Okay. Further concepts we will see in the next video. Till then, thank you and take care all. Welcome back to the science class. Students, in the previous video, we have understood an activity to verify laws of reflection. Yes, the very first law of reflection, that angle of incidence is equal to the angle of reflection, was verified with that activity. In this video, let us understand two new terms related to reflection of light, that is regular reflection of light and irregular reflection of light. So let's begin. We are learning chapter number 16, reflection of light. Yes, students, let us together understand what is regular reflection of light and irregular reflection of light. Okay, this is figure 16.4, reflection of light from a smooth surface and a rough surface. So figure 16.4a is smooth surface and 16.4b is rough surface. If you observe it closely and carefully, we get to understand a relation between angle of incidences, many angle of incidences, in fact, I1, I2, I3, and many angle of reflections, R1, R2, R3. Yes, figure 16.4a and b, they show three parallel rays. Yes, incident rays. Three parallel rays are there. Can you see three blue lines and three red lines? Okay. Parallel rays which are shown in blue and incident on both the surfaces, smooth and rough. The reflected rays drawn using laws of reflection, they are shown in which color? Red color. So incident rays blue color, reflected rays are red in color. Now the question arises here. Rays which are reflected from which surface are parallel to one another? Rays reflected from which surface are parallel to one another? Please look at the figure. I think figure 16.4a. Clear parallel lines can be seen. Yes? What conclusion can you draw from the figure? Rough surfaces, if I compare, parallel lines are not seen. But at any particular point, angle of incidence and angle of reflection are same. Yes, but we don't see any sequence of parallel lines for rough surface. Correct? So students, let us understand regular reflection of light, which is our first term that we need to understand. The reflection of light from a plane and smooth surface is called regular reflection of light. Simple. Any plane surface, any smooth surface gives you regular reflection of light. For regular reflection, the angles of incidence, I'm not talking about one angle of incidence, I'm talking about angles more than one. The angles of incidence as well as of reflection are the same for all parallel rays falling on the surface. Yes, they are same for all parallel rays. Yes. Thus, the reflected rays are also parallel to one another. Yes. So, I1, I2, R3, R1, R2, R3, they all are parallel to one another. Now, if suppose the angle of incidence for incident rays are I1, I2, I3 and their angles of reflection are denoted as R1, R2 and R3 respectively, then students remember one thing. I1, that is angle 1, yes, is equal to I2 is equal to I3. Similarly, R1 will be equal to R2 will be equal to R3. Okay? And this is the explanation of figure 16.4a students. Okay, smooth surface. Plain smooth surface is required to be called it as regular reflection of light. Understood this? Okay, so let us see irregular reflection of light. Okay, from the figure only you can make out it is not plain. No? It is not plain, it is rough, it is not even. So reflection of light from a rough surface is called irregular reflection of light. In irregular reflection, students see carefully, the angles of incidence for parallel rays of incidence are not equal. Yes, here can you see I1, I2, I3, they are not equal to each other. At one point, all are making different angles. Yes. So, in irregular reflection, the angles of incidence for parallel rays of incidence are not equal. Therefore, their angles of reflection will also be not equal. Understood? So, I1 is not equal to I2 is not equal to I3. So, R1 is not equal to R2 is not equal to R3. Understood? Thus, the reflected rays are not parallel to one another and spread over a large surface. Okay. This is clear from the figure 16.4. So the reflected rays are not parallel to one another also and they spread over large surface. If you see I2 and R2, they are making larger angles. I3 and R4 are making smaller angles, and then R1 and I1 both are making different angles. That means I1, I2, I3 are not equal. R1, R2, R3 are not equal to each other. Understood? So for a rough surface, we can imagine this kind of picture, this kind of reflection of light occurs for rough surfaces. Okay. So what we have to remember, students always remember that laws of reflection are followed in both regular and irregular reflection. Now the question arises, teacher, only for smooth surfaces this laws are reflected or laws of reflection are followed? No, it is for both regular and irregular reflection. The reflection of light in irregular reflection has not been obtained because the laws of reflection are not followed. Yes, but they are obtained because the surface is rough. Okay, reflection of light is has not been obtained because it is not following the laws of reflection, but it is obtained because the surface was rough, surface of irregular. So because of this reason the reflection of light can be seen. Okay, always remember one more thing, students. In irregular reflection, the angles of incidence at different points are different. Correct? I told you at one point, yes, at one point, at any one point, the angles of incidence and reflection are equal. That means I1 is equal to R2, I2 is equal to R2. I1 R1 equal, I2 R2 equal. But the angles of incidence at different points will be different. Please go back to the figure. Here you will understand. Here can you see I1 R1 is equal, I2 R2 is equal, and I3 R3 is equal. But I1 is not equal to I2 and I2 is not equal to R3. All are making different angles, yes, on the rough surface. So I hope you have understood the explanation for these two important terms. What is regular reflection of light and irregular reflection of light? Further concepts we will see in the upcoming videos. Thank you. Welcome to Fresh Morning Standard 8 class. Students, happiness is the only thing that multiplies when you share it. Correct? So let us move to the next concept of lesson number 16, reflection of light. Students, in the previous video, we have seen the definitions for regular reflection of light and irregular reflection of light. In this video, let us understand concept known as reflection of reflected light. Yes, you heard it right. Reflection of reflected light. The light which is already reflected, again it will undergo reflection. Okay, and we are going to see this with certain examples. So let's begin. We are learning chapter number 16, reflection of light. We are going to understand concept known as reflection of reflected light in detail. Students, we have to answer few questions here. How do you see if the barber in a salon has cut the hair on your neck properly or not? Yes, students, if you observe carefully in the salon, there are mirrors in your front and back. The image of the back of your head is formed in the mirror at the back. Now the image of this image is formed in the mirror in front of you. Correct? The image of this image is formed where? In the mirror which is front of you. Thus, you can see how the hair at the back side of your head is cut. Most oftenly, you must have observed this, experienced this. Next question here we have. How do we see the image of the moon in water? Students, we know that moon is not self-luminous. The sunlight falling on the surface of the moon is reflected. Okay. Now this reflected light is again reflected by the water to give us the image of the moon. So reflection of reflected light is what we are talking about. In this way, light can be reflected how many times? Several times. It can be reflected several times. So students, let me introduce you to a kaleidoscope. Here we are going to understand how to form this kaleidoscope. So let's begin. This is an activity. We have to take three rectangular mirrors of the same size. I'm talking about rectangular mirrors, okay? Using sticking tape, stick the mirrors together making a triangle. You have to make a triangle out of this rectangular mirrors with a reflecting surface facing inside. So obviously, the reflecting surface would be inside. Okay, we are going to see the figure 16.5. Now what I have to take? I have to take white paper of triangular shape and fix it with tape at one end of the mirrors closing that end. That means I have to cut a white paper of triangular shape. Yes, triangle shape I have to cut, and I have to fix it with the tape at one end, and I have to close one end of the uh, rectangular mirror that we have formed. Okay, one end will be closed with the white paper. This is the figure 16.5 kaleidoscope. If you see on my left hand side, there is a cap for closing. So this is made up of paper here, which is triangular in shape. Okay, and then we are going to see on the from the other end. Okay, so this is kind of cardboard tube inside this rectangular mirrors which are sticked with the help of the tape. It is placed inside this cardboard tube. Okay, so this is kaleidoscope. What we have to do next, I have to insert 4 to 5 colored glass pieces. Okay, different color glass pieces we get, we have to insert this in the hollow of the mirrors. Means wherever there is space inside there will be hollow, no? Because once we arrange them in triangular shape, inside it will be hollowed. In that we are going to place glass pieces. We are going to close the other end with the paper and make a hole in it. Okay, if the left hand side end is closed with white paper, the other side also I'm going to close it, but I'm going to make a hole in it. From there I'm going to observe. Now I'm going to see. Look through the hole towards the light. You will see innumerable images of the glass pieces. Okay, we all know kaleidoscope. Okay, what it is. These are formed due to reflections by the three mirrors. Yes, we have used three rectangular mirrors and we have arranged and we have formed a kaleidoscope. Okay, so if you look through the hole towards the light, okay, what we will see, students, we will see innumerable images of the glass pieces which we have placed inside. So this is the kaleidoscope. It is based upon the concept reflection of reflected light. I hope you have understood this. In the next video, we are going to talk about periscope. So stay tuned and observe all the videos. Thank you. Welcome back to the science class. Students, in the previous video, we have seen a kaleidoscope, which is based upon the concept reflection of reflected light. In this video, let us understand periscope. Okay, periscope, yes, on submarines, that we are going to understand in this video. So let's start. We're learning chapter number 16, reflection of light. So this topic comes under reflection of reflected light. So the topic is periscope. Okay. So before that, we will do a small activity. Okay. Take a cardboard box. Take a cardboard box. Make slits in the top and bottom sides of the box. You have to make slits. And place the two mirrors so that they make an angle of 45 degree with the sides of the box and are parallel to each other. So here we are going to place two mirrors making an angle of 45 degree with the sides of the box. And see to it they are parallel to each other. How we are going to fix them? We are going to fix them with a sticking tape. I am going to show the figure 16.6 after this. Now what I have to do? I have to make two windows of 1 inch each near the two mirrors. Okay. So we are going to make two windows and now I am going to see through the bottom window. So two windows of 1 inch each near the two mirrors, right? So whatever we see, we are going to make a note of it. This is what I am talking about. Can you see this eye symbol? From here we are going to observe it. Okay, light rays, can you see yellow colored, these lines are drawn, that is nothing but the light ray. And 45-degree angle we are going to make with the box, that is what they have shown. So let us understand more. From the bottom window, students, one can see what is in front of the top window. Whatever object we place in the top window, it is seen from the bottom window. This device is called a periscope. Now, where I am going to use periscope? Periscope is used in submarines to see objects above the surface of water. Yes, this is an equipment, this is a device which is used in submarines to see any object above the surface of water. Now it is also used to observe and keep a watch on the objects or persons on the ground from an underground bunker. So this is also one more function of periscope. This is the periscope. Can you see? Gray colored structure which is shown, which is, okay, this is a part or this is an equipment or device which is installed in the submarines. Periscope. Okay, very important point to be noted here is kaleidoscope and periscope both use the properties of reflection of light. We have seen that light gets reflected several times. So we are using the properties of reflection of light. We understand kaleidoscope and periscope. Okay. So I hope you have understood this. Yes, next videos we will be talking about numerical problems, solved examples from your textbooks. Okay. So for now, thank you and take care all. A very good morning, standard 8th class. Students, when you are enthusiastic about what you do, you feel this positive energy. It's very simple, right? With this note, let us move to numerical problems, that is solved examples of lesson number 16, reflection of light. Okay, so let's get started. We are learning chapter number 16, reflection of light, numerical problems. So in this we are going to see solved examples from our textbook. So the very first numerical problem is, if the reflected ray makes an angle of 60° with the normal, what angle must the incident ray make with the normal? Got it? So what is angle of reflection? Angle R, yes, is 60°. We all know that angle of reflection is denoted by small r and angle of incidence is denoted by small I. So angle of reflection, angle R is how much, students? 60°. And what we have to find? We have to find angle of incidence. That is angle of I is equal to what? Question mark. We all know the law of reflection, right? The very first law of reflection, that the angle of incidence is equal to angle of reflection. So whatever will be the measure of angle of reflection will be the same for angle of incidence. So angle I is equal to angle R. But R is how much? 60°. So angle I will be also 60°. So the incident ray will make an angle of 60° with the normal. Simple. So based on law of reflection, we came to a conclusion that angle of incidence will be 60° only. Simple one. Okay, so let us see the next numerical problem. Yes, the second question we have is, if the angle between the incident ray and the reflected ray is 90°, what are the values of the angle of incidence and the angle of reflection? I repeat the question, angle between incident ray and reflected ray is how much? 90°. So we have to individually find out values of angle of incidence and angle of reflection. Okay. Now what is given? Angle between the incident ray and reflected ray is 90°. Okay. That means addition of angle I plus angle R is equal to 90°. Yes, the meaning in mathematical way we will write angle I plus angle R is equal to 90°. Now, according to the law of reflection, angle I is equal to angle R. Angle of incidence is equal to angle of reflection. So what I am going to do, I am going to put, instead of angle R, I am going to write angle I. Okay, I can do this because both are same, na? Both are equal. So angle I plus angle I is equal to 90 degree. So 2 times, that is 2 angle I is equal to 90 degree. That means angle I, yes, is equal to 45 degree. That is angle of incidence is 45 degree. This is what we have found out. So can we find out angle of reflection? Yes, we all know that according to the law of reflection, angle I is equal to angle R. That means if angle of incidence is 45 degree, angle of reflection is also 45 degree. So this is like a simple mathematical word problem kind of sum it is, where we find angle I value and then we relate it with law of reflection. So both angle of incident and angle of reflection have the same value, that is 45 degree. Always remember that angle between the incident ray and reflected ray is 90, means we have to add here angle I plus angle R is equal to 90 degree. This particular equation we have to write and then we have to solve and we have to get the answer. Okay, understood this sum? Very simple to understand. Okay, so with this I have completed 2 numerical problems. Next video we are going to discuss the next 2 numerical problem. Till then, thank you and take care all. Welcome back to the science class, students. We have seen 2 solved examples, okay, as numerical problems for lesson number 16, reflection of light. In this video, let us understand the third and fourth solved example which is given in your textbooks as numerical problems. So let's begin. We're learning chapter number 16, reflection of light. Okay, so in this video, let us understand numerical problems, that is solved examples third and fourth. Okay, this is your question number 3. The angle between the plane mirror and the incident ray is 35 degree. What is the angle of incidence and the angle of reflection? This is what it is asked. If you see the figure 16.2, line PQ is a mirror, line AO is the incident ray, ON is nothing but your normal, ray OB is the reflected ray. This is the very own picture where we have understood laws of reflection based on this particular figure. The same figure we have to always use this. For question number 3 and 4, we have to use the same figure 16.2. So in the textbook, they have directly given in figure 16.2. But what I have done, while explanation, I am going to keep this particular picture so that it becomes easy to understand. Okay. Now from the figure, students, tell me what is angle POA. In the question it is given. Yes, the angle between the plane mirror and the incident ray. That means PQ is a plane mirror and angle POA is equal to 35 degree. Now PON is how much? 90 degree. We all know that 90, na? That is normal. Its measurement is 90 degree. That is 90. Because the perpendicular is drawn. Now what is normal? ON is nothing but the perpendicular line that we have drawn. Yes, on PQ. So now you tell me, this is simple mathematical, geometry based concept where angle POA plus angle AON is equal to angle PON. Understood? Angle POA plus AON is equal to PON. Okay. POA is 35 from the question it is given. Angle AON is something that we have to find out. And PON, we all know it is 90 degree. Correct? Now angle AON will be 90 minus 35. This is how, after calculation we can find it out that angle AON is for 55 degree. That means that is angle of incidence, right? So I is 55 degree. According to law of reflection, we all know that angle of incidence is equal to angle of reflection. So what will be angle of reflection measurement? Same 55 degree. So what was the question, students? We have to find angle of incidence and angle of reflection. So after solving this sum, I got angle of incidence value. And by using law of reflection, what do we get? Value for angle of reflection. That is 55 degree. Yes, understood this sum? Always we have to refer figure 16.2 for this type of numerical problem. So I hope you have understood this. Let us see the next one. Question number 4. What angle will the reflected ray make with the mirror if the angle of incidence is 40 degree? So what is given, students? Now angle of incidence is given as 40 degree. Okay, let us see the explanation. Same figure I have to take. Now angle QON is equal to 90 degree. Normal, yes, we know that QON is 90 degree. Now angle of incidence, how much it is given? 40 degree. I is given as 40 degree. Now angle NOB is equal to angle R, which is equal to 40 degree. Now according to law of reflection, I can write down the value of angle of R, that is angle of reflection, as 40 degree, as both are equal. The first law of reflection says that angle of incidence is equal to angle of reflection. So when they have given angle of incidence as 40 degree, students cannot take angle of reflection as 40 degree. Yes. Okay. Now same mathematical geometry based concept here I am going to use. Angle NOB plus angle QOB, yes, is equal to angle QON. So put the values. NOB is 40, QOB is, I have to find out, which is equal to 90 degree. QON is perpendicular, na, normal, that means it is 90 degree. So what is measurement of angle QOB? Students, it is 90 minus 40. We are going to take 40 on my right hand side, and the answer is 50 degree. So the reflected ray will make an angle of 50 degree with the mirror. Simple sum. So other way around, what we are going to do? We have to first relate angle of incidence and angle of reflection with the help of law of reflection, and then we are going to find out the value for the reflected ray. What angle does it make with the mirror? Understood? Okay. With this, students, we have completed the chapter 16, that is reflection of light. Immediately after this video, you are going to get a PDF of question answers. Go through the lesson twice and then sit and write the PDF of question answers. Understand it. Go through the 2 numerical problems which is there in the question answers. It's really simple. Okay. Till then, thank you and take care all.